Question 9. Two particles oscillate horizontally. The displacement of the first is given by x equals 3 times sine of 4t, and the displacement of the second is given by x equals a times sine of nt. In one oscillation, the second particle covers twice the distance of the first particle, but in half the time. What are the values of a and n? Let's call the first particle particle P and the second particle particle Q. Let's consider the distance covered in one cycle for particle P. So starting at the origin, its amplitude is 3. It moves to the right hand side 3 units until it gets to the maximum extent away from the origin, and then back 6 units to the left hand side until it gets to x equals -3, and then back 3 units until it arrives back at the origin, and that's one cycle. So 3 plus 6 plus 3 is equal to 12. Let's consider particle Q. Now the distance is doubled. This implies that the amplitude is doubled. But let's check this. So starting at the origin, the particle moves to x equals +6, so that's 6 units. Then it moves back 12 units until it gets to x equals -6, and then it moves back to the origin 6 units until it gets back to 0. So the distance covered is 6 plus 12 plus 6, which gives us 24, which is obviously double 12. Hence, A is equal to 6. If you recall, the amplitude is the distance between the origin and either the maximum or the minimum extent of travel. Now consider x equals sine of nt. If we double n, the coefficient of the time variable t, this will halve the time taken to complete one cycle. In other words, it doubles the speed of the particle. So for particle P, x is equal to 3 times sine 4t. For particle Q, x is equal to 6 sine 8t. Therefore, the correct answer is option D. A is equal to 6 and n is equal to 8.